This is the introductory section to a half-day seminar on software development project management. This introductory section covers the reasons that software development is different from other kinds of projects, the dominance and seeming inevitability of Agile project management, and some of the reasons why Agile isn't working for some people. Expedient training that imparts a formulaic knowledge of Agile and a dogmatic attitude about some forms of Agile means that a lot of training material that's out there today is inadequate. The result is bad Agile. This is intended to prevent bad Agile happening to you and to help repair situations where Agile project management has lost credibility with the project teams it is supposed to help. In 2011, Mark Andreessen, founder of the enormously successful venture capital firm Andreessen Horowitz, famously said, "Software is eating the world." What did he mean by that? He meant everyone in every business, policy-making domain, and research area needs to know how to create value, solve problems, and support their work by creating software. That is easier said than done. Software creation is different, and software development projects differ from other projects undertaken in business and other enterprises. Software development projects require a special kind of project management. This new way of managing projects is simple, but it is not easy. This is for people who want to make good software. Good software creates value. Good software projects result in useful software that creates a lot more value than the cost to make it, and that can be updated, extended, and maintained at reasonable cost and within reasonable schedules. Outside of the context of business, software increasingly powers access to government services, government data, and it also informs policy decisions. In universities and research organizations, software has become a key element in processing research data. Whether you and your colleagues are creating software or you are hiring software developers to make it for you, you need to know how to manage that process. The unique nature of software development has strained the abilities of conventional project planning and management. A new approach was needed. The Agile approach to project management has therefore spread rapidly. In fact, Agile has been so successful that it has spread faster than the knowledge and experience needed to do it well. Here you will learn why Agile is different from what came before and why it is a good approach to managing software creation. You will also learn how to avoid the pitfalls of the ways in which Agile has become a fashionable and jargon-heavy dogma. You could call this, what we're talking about here, Manifesto Agile. Some people, especially those familiar with the Manifesto for Agile Software Development, may find it to be a hint as to what my views are regarding Agile project management practice. Software is different. The need for software is urgent. Creating software needs a new way of managing. Not surprisingly, demand for knowledge about how to manage software creation outstrips the supply of real experienced wisdom. To meet the demand for managers to run software development projects, training in what is called the Agile approach is often expedient and certification-oriented. The people who come out of this training often know some of what to do, but not the deeper reasons why they should do it. Here we enable project managers to be more effective, better understood, and better appreciated by their colleagues. This knowledge journey combines the mechanics of Agile project management with the reasons why it is needed, why it works, and why it sometimes fails. Most training material about Agile focuses on getting the reader a certification. Professional training and certification is useful and practical, but that training does not prepare the trainee for skeptical or disinterested colleagues, for defending a novel approach to managing, for building relationships outside an organization's software development teams, and for avoiding the all-too-common outcome that Agile is practiced in name but not in substance. On the other hand, an Agile project manager's colleagues can use this knowledge to create a better environment for nurturing software development. This knowledge is useful to everyone in an enterprise who wants to make better software, communicate better with their colleagues about making software, and make better decisions about what software to make. General Alfred Gray, the 29th Commandant of the U.S. Marine Corps, famously said, "Every Marine a rifleman." He meant that every Marine must be trained and ready to take up a rifle and fight, even the cooks, truck drivers, and supply clerks. Now one might say, every business a software business, because every business and every institution needs to know how to create software in order to reach their goals and improve the way they function. One might also say, every business person a software person. Many organizations now create and use software technology outside the traditional scope of the IT department. There's a very good chance that your organization is an organization that creates software, whether or not your senior leadership is aware of it. Products of all kinds contain an ever-increasing amount of software for a wide range of reasons. Software is easier to change than manufacturing tooling. Sensors have become inexpensive, so products can sense their environment and adjust how they work. Ever more products communicate with smartphones and the internet instead of being self-contained. Even the primary and secondary industries that make or extract bulk materials like cement or coal produce data about their products, how they are used, and how they perform. Extracting value from data takes software, often advanced software like machine learning and AI. Software enables customers and the supply chain to automate a variety of interactions and create more value in all kinds of products. Governments find they need to create software to enable access to government services. Much government data is acquired and made available through mechanisms known as application programming interfaces, or APIs. This enables software created by third parties to integrate government services and data into their software. Maximizing the availability and usability of data is a key aspect of delivering quality governance and accountability. Now that software creation is the business of nearly every enterprise and government, the activity of software creation demands the attention of anyone who intends to keep their career close to where value is created. These are among the wider trends driving software into aspects of the enterprise outside of the traditional IT department roles in company operations. Migration of product features from hardware to software. Smartphones everywhere. Analytics driving decision-making. Linkage and communication within enterprises and among cooperating enterprises. Networks of sensors and digital radios. Machine learning, ML, and artificial intelligence, AI. The ways in which software now permeates commerce and government puts software creation at a critical position in more organizations than ever, and makes it a key factor in commerce and in the value produced by commercial enterprises and the public and nonprofit sectors. How do managers on the technology and business sides of an organization keep software development on track? How do the people who started a software project ensure that the outcome is what they want? In the early history of software, the answers came from the management of large projects in aerospace, construction, and civil engineering. Project staff gathered requirements from departments in the enterprise and produced documents describing the requirements to designers. Designers then produced documents describing the design. Software architects then produced an implementation specification document for the coders, who communicated through test plans with testers, and so on. This set of project documents was produced to inform traditional project management approaches. They often came to thousands of pages and had names like functional specification and design specification. Project managers used tools called Gantt charts and critical path analysis to create precise schedules that spanned entire projects. This highly structured way of managing projects seemed to be sensible and responsible. Project teams and managers can't meet a schedule without knowing if they have the human and capital resources to do so. Sophisticated project management software is capable of automatically optimizing resource allocation to create the most efficient schedules for who does what and in what order. The purpose of traditional project management is to mitigate waste and risk, and to predict the cost and duration of a project with exquisite accuracy. That is the goal. The track record of this seemingly prudent approach to project management, when applied to software creation, is quite another thing. The linear, document-driven specifications and implementation process of traditional project management is sometimes called the waterfall model because of its resemblance to a stream cascading from one level to another. During the 1970s, computer scientists sought to formalize good practices in project management. Software development projects were expensive in terms of both people and capital equipment. The great expense, long duration, and large engineering teams characteristic of early software development projects were on par with other complex engineering projects. Winston W. Royce, a computer scientist at Lockheed Corporation, first laid out what came to be called the waterfall model as he sought to formalize the planning and execution of software development projects in a 1970 paper titled Managing Development of Large Software Systems. Before deep dissatisfaction with the results of the waterfall model prompted the development of the Agile approach to software development project management, this was the standard for adapting the systems analysis style of project management to software projects. When applied to software development projects, strains in the waterfall model became apparent from the beginning, even more so in the context of inexpensive ways to deliver and host software. Software requires creativity and innovation. Software embodies, indeed embraces, more risk throughout its development than, for example, a civil engineering project to build a highway overpass. No one would start building an overpass until a plan was in place that detailed every step of the project. Improvisation and deliberate risk-taking is avoided. In terms of embracing risk, software is fundamentally different, enough so that software project management must be designed specifically for the different nature of software. Winston W. Royce noted the fragility of what became adopted as the waterfall model in the paper where he describes it. I believe this concept, but the implementation is risky and invites failure. The testing phase, which occurs at the end of the development cycle, is the first event for which timing, storage, and input-output transfers, etc., are experienced as distinguished from being analyzed. These phenomena are not precisely analyzable. They are not the solutions to the standard partial differential equations of mathematical physics, for instance. Yet, if these phenomena fail to satisfy the various external constraints, then invariably a major redesign is required. A simple octal patch or redo of some isolated code will not fix these kinds of difficulties. The required design changes are likely to be so disruptive that the software requirements upon which the design is based and which provides the rationale for everything, are violated. Either the requirements must be modified, or a substantial change in the design is required. In effect, the development process has returned to the origin, and one can expect up to a 100% overrun in schedule and/or costs. In other words, even though it looks prudent, comprehensive, and informative, the waterfall model can't eliminate bad surprises that cause large delays. If you have recently participated in a software development project, the waterfall model may seem unworkable even at first glance. Who would tolerate a system where coding begins in the 5th step of the waterfall cascade? Extensive specification and planning before coding might have made sense decades ago when Royce formalized the waterfall model. One reason for the amount of upfront planning at that time was that computers were very expensive, literally tens of millions of times more expensive per unit of processing power and memory as they are today. Software development work that wasted computing power was to be avoided. With the availability of modern tools and frameworks for apps and awash in an ocean of computing power, delaying coding so late into a project is plainly not productive. Nevertheless, it is worthwhile knowing that there are deeper reasons why software development projects needed a fundamentally new kind of project management. Software has unique characteristics that make it different from other kinds of things companies make and sell. Software gets delivered to any number of customers at nearly zero incremental cost per new customer. There's no difference in cost for delivering it here or on the other side of the planet. There's no such thing as a software factory. There are no limits on how much software can be used or by how many people. Unlike the output of a factory, every copy of a piece of software is a perfect copy. Once software that does something has been created, it does not need to be created again. Almost all the software an organization makes should be unique. The differences go deeper still, especially as they apply to project management. You might be looking at this material because you want to have better task estimates and better predict the outcome of projects and their schedules. If that's what you want, give up now. A topic we will explore in depth is that software development tasks are much harder to estimate than tasks in almost any other kind of project. The numerous consequences of this seemingly simple fact is what makes software development project management unique and difficult, even though software development projects may look uncomplicated compared to projects that result in, for example, building a building. Software as a service, or SaaS, has further reduced the cost of delivering, using, and updating software by providing the underlying computing as part of the cost of using software. SaaS has fueled an enormous increase in startups by removing a lot of capital equipment from startup budgets. At the height of the so-called dot-com bubble, every software startup had to invest in server hardware and the database software to go with it, frequently in the form of Sun Microsystems server hardware and Oracle database software. Every ambitious startup had to allocate hundreds of thousands to millions of dollars to the ability to deliver their product to customers. Now Sun is gone, and Oracle is not a factor in most startups' plans. A startup can get started with a virtual server, or instance, in Amazon's cloud. While costs will climb as customer numbers grow, a startup can spend just a few tens of dollars per month to launch a product hosted in a cloud provider's servers. Often the database, web server, operations dashboard, and other tools are included in the price and are free and open source software. The characteristics of modern software creation and delivery has profound consequences to investment in software, and to how enterprise financial and strategic management should evaluate their spending on software development. This is a different economics of software on a world-changing scale. The result is a shift in focus to issues like time to market for new software products. Managing software creation appropriately in the new context is ever more the critical factor in success. Where the circumstances of building a bridge change at the pace of geology, software projects must respond to fast-changing needs with a time horizon of months or weeks. Responsiveness to change has a lot of value. Software designed 2 years ago is unlikely to be the best solution today. Forgoing the lengthy planning phase of the waterfall model makes it a requirement that projects learn and adapt as they proceed. The problem with responsiveness in the waterfall model is the time and effort needed for replanning. The analysis that goes into making precise schedules that optimize each individual's work over the entire project must either be discarded and redone every time a schedule slips or a new requirement is discovered, or the reality of a project becomes disconnected from the project plan. Why make such thorough plans when you expect to have to change them often? Responsiveness to changing requirements is one reason why many products have moved from being mechanical and analog to incorporating digital processors and memory and software. Software permits rapid modification and innovation without production retooling. As software becomes central to competitiveness and enterprise value, requirements for software are changing at an accelerating pace. The waterfall model is therefore not practical for most software development projects. Moving forward, you have a choice. You can look at the superiority of Agile as giving you no option but to use it. If you take that view, does it really matter how well you use it? It's the only choice. Or you can say to yourself, I've really got to learn how to use the Agile approach well. I've got to understand it down to its origins, fundamentals, and all the motivating factors that go into why Agile replaced what came before it. When it's done right and adapted to your unique needs, Agile is the best tool to get software done.